Morning students. Today I am Suman. Today we will solve some numerical problem of class 9 physics in relation to force and law of motion. Previous day we haven't already discussed the Newton's force, Newton's law of motion, second law of Newton's second law of motion. Today we will see some problems which is based on the Newton's second law of motion. There are two questions here as you are watching. The question is calculate the momentum of a toy car weighing 200 gram and moving with the velocity of 5 meter per second. So before solving the numericals, we will write the information whatever given in the question. And the information is means mass is given 200 gram. So first we will convert all the physical quantity in SI system. So we will divide 200 by 1000. When we will divide gram by 1000, it will convert into kg. And the SI unit of mass is kg. The value when we divide, it becomes 0.2 kg. This is the first information. Second information in this question is the toy car is moving 5 meter per second. So here velocity equal to 5 meter per second. We have two physical quantity, it is mass and the velocity, and in this question we have to find out the momentum. And the formula of momentum, and momentum is denoted by P equal to m into v, and we will put here the value of mass and the velocity. The value of mass is 0.2 kg and the value of velocity is 5 meter per second. As we will multiply it, it's become 1.0 kg meter per second. So when the object or toy car moving with 5 meter per second weighing 200 gram, their momentum becomes 1 kg meter per second. This question is based on the momentum. Second question is a cricket ball of mass 70 gram moving with a velocity 0.5 meter per second. It is stopped by a player in 0.5 second. What is the force applied by the player to stop the ball? So in this question we have to find out the force. As we know that from Newton's second law of motion, force F equal to m into A. First we have to find out the acceleration in this question. Then we will find out the force. The solution of question number 2. First we will write the information whatever given. In this question m is given 70 gram. It means this is not in SI system. First we will convert this in SI system by dividing 1000. So 70 gram by 1000. So when we will divide gram by 1000, it's become kilogram. 0 is cancelled. It's become 0.07 kg. There are 20 as a denominator, so I will put 2 decimal place of numerators. Second is given, the velocity is moving. Actually in this case the object is moving, and after 5 seconds the stop becomes stop. So here the object is moving, this is means initial velocity, and initial velocity we denote u equal to 0.5 meter per second, and object is stopped means this is the final velocity, so v equal to 0. And what is the time? Time is 0.5 second. So t equal to 0.5 second. Now we have u, v and t. We'll move the first equation of motion, which is v equal to u plus a2, and we'll put all the values. V is 0, u equal to 0.5 plus a, we have to find out a in this case, so a, and t is 0.5. This term will come this side, either this term will come this side, so minus a into 0.5, 0.5 equal to 0.5. So a equal to 0.5 upon minus 0.5, 1 meter per second square. SI unit of acceleration is meter per second square. Now we will apply it, and this A is negative. Negative sign shows the retardation. Retardation means when the object is moving and stop after applying a opposite force. So in this case, the object is moving and going to stop or going to rest. So in this case, negative sign shows the retardation. Now we will put this value. In this case, we have mass 0.07 kg and we have acceleration minus 1 meter per second square. So F force equal to mass into acceleration m into a, and m is 0.07 and acceleration is 1 meter per second square, here kg. So it's become 0.7 kg meter per second square or 0.07 Newton, because Newton is the SI unit of force. So you will try to solve the exercise question of this chapter, force and law of motion, which is, and the numericals, which is based on the Newton's second law of motion. And next day we will discuss the Newton's third law of motion. Till then, thank you.